Hey YouTube, another video, and as you saw a few days ago I published a video, a short one, a sneak preview showing how I took an inkjet printer and sort of turned it into this plotter thing, which you can see in front of you. And this video is going to be the first part of this conversion, and it's mainly going to discuss how I achieved this state, which parts I've added, which parts I've removed, which mechanisms I had to change a little bit to get this thing to work, as you saw at the beginning of this video. And aside from that, I'm also going to include some videos showing how I started working on the code part and basically working towards the second part of this tutorial, which will deal mainly with the code and the software that runs from the computer itself. So this part is going to deal with the printer itself and how to change it and how to make all the necessary changes for those of you who are thinking of doing the same thing, the same project, just for fun. I'm doing everything for fun. It's not a commercial thing. It's not something that's going to compete with actual plotters. It's again just something to learn from, and that's it. But let's get started. I was thinking a few days about how am I going to make this tutorial. Some people wanted that I make an instructable about it, but I don't see a real way of providing instructions for this kind of project. The printer, it's just a random printer that I received from someone who threw it away, and if you're going about this, then most likely you will have a different model printer, and there are all these variables inside included that I can't really give any clear instructions to what you need to do, but I can give guidelines and tips and changes that do need to take place. It can't be done on any inkjet printer, even though they all work on the same principle, but just because the way they are built and designed with different models, it's not that easy to convert any inkjet printer to it. So first of all, I will address some questions just to get that out of the way. The first question is, can you do this with any printer? The answer is no. You need to have an inkjet printer as opposed to a laser printer. An inkjet has both an X and a Y axis, and you get the X using by this carriage mechanism, which moves from side to side, and the Y you get from the paper conveying mechanism that will move the page on the Y axis. And you don't have that on a laser printer, so an inkjet printer is necessary. The second question would be, can I do this with any inkjet printer? In principle, the answer is yes. All inkjet printers, they work on the same principle. They have this X and Y axis, and it will work in that fashion. But then comes the issue of design, how the printer itself was built, and how difficult it will be to make all the necessary changes. And we're going to start with the changes that took place here. Before I start, some key elements that you want to look into an inkjet printer if you have one lying around, or if you're looking to buy one like a second hand or a broken one and make these changes. There are several things that you want to look for to make your life a lot easier. The first thing is you want to have a rear feeding printer, so that means that the pages, they feed from the rear of the machine and they are conveyed to the front, as opposed to machines that would feed the page from the front, from the bottom here, and then turn it inside, and again the page will come out from the front. The main reason for that is because one key thing that you need to do is you need to remove the paper feeding mechanism. And the paper feeding mechanism, as you can see, it's this module here. I removed the entire module, and this one sat here at the back, and you need to remove this because the way the printer works, it has two motors basically, one motor dedicated for the carriage unit and another motor which sits here, and this motor will run several functions depending on the position of the carriage, and it will do that using clutches and levers. The first function that it will do is feed the paper using the mechanism I just showed you. It will feed the page, and then a sensor will detect when the page has reached a position where the paper conveying mechanism can take over, and then the paper conveying mechanism will take over once this carriage has moved from the away from the home position. So the carriage will go a bit like this. A lever at the back will be stopped, which will engage a clutch, and that will cause the paper feeding mechanism to disengage and the paper conveying mechanism to start pulling the page inwards. If the motor runs in a different direction, in the opposite direction, sorry, while this carriage unit is at its home position, then the paper feeding mechanism is disabled, also the paper conveying, and it goes into, we have the ink absorbing mechanism which is operated, and it has this thing which sat here, and it basically just goes up and down, absorbing the ink from the print head. And we also have the ink residue pump, which is this unit right here, which you also need to remove from the main mechanism, and this will convey the excess ink and move it into an ink absorber. This is an example of the ink absorber. It's just a pad. In some machines this pad is located somewhere around here. Other machines have this pad all over the bottom of the machine, and essentially through time this entire pad will be filled up with excess ink. Those are the major changes that need to take place. And as I mentioned, you want to have a rear feeding printer, because then all those mechanisms are easily accessible. Where if you have a front feeding machine, then this whole mechanism will be at the bottom of the machine. That means that you need to take everything out, you need to disconnect this mechanism, and then you need to put it back in. And the thing is that once you put it back, you will probably lose some key calibration that took place with this printer, and maybe the page will not feed, will lose its alignment, it will not feed in correctly, and then you lost a great deal of the accuracy, and it's difficult to get it back just without any knowledge of which things you need to adjust here. So that's the first thing. You want to have a rear feeding machine. The second thing you want to have is not a low-end type printer. This one is the mid-range one. One easy way to tell them apart is by the amount of cartridges that they use. This one used 4 cartridges. You have ones that use 5 or 6, but the low-end ones, they will use they will only use 2 cartridges, and that also is an indication that it's a low-end machine. And the problem with the low-end machine is that they're all made to be very cheap as far as production goes. The aim is to make everything, all the sensors will be part of a main circuit board, and you need to preserve the sensors for the stepping, for the position wheel, and also the position strip here. There are sensors that read it. You need to use them. Here you can see I have the sensors for the carriage unit right here. I took them, I separated them, and also for the wheel here. And you need to have them apart. You need to have them like this individual unit that is just screwed somewhere, as opposed to for example, this is a print plate from a different printer, and you can see that the position wheel sensor is mounted on the main circuit board, and you need a sensor, so that means that you need to salvage it, and then you need to make your own circuit out of it, just like this one, adding a capacitor and a resistor and put it on your own print plate, and then also making modifications to the frame or adding something where you can easily mount this in a precise way. And this needs to be both in the position wheel for the paper conveying mechanism and also for the carriage unit. So that's the second thing that you need to look into a printer. The next, so as I said, you need to remove all these mechanisms. You need to remove, you basically want to be left with only two modules. This module, which is the carriage unit, and it includes this bar, everything, you want to keep this module intact. When you're taking the printer apart, you don't want to start just randomly removing screws. You want to take it apart from the outside towards the inside, but then you look at each screw that you need to take apart and not accidentally taking screws that belong to the module itself, but just the ones that connect the module to a different module. So again, you only need two modules, and that is the carriage unit and the paper conveying module, which is this entire thing here. And those are the only two things that you need. All the other mechanisms, they need to be separated. That includes, again, the paper feeding mechanism and also the ink absorbing mechanism and the ink pump itself. Other printers, they will have more functions. So if it's a higher end printer, it might have double-sided printing, so there's another mechanism that you need to disconnect. If it has CD printing, another mechanism that you need to disconnect, and so forth. So that's why a mid-range printer would probably be suitable. Then there is also the issue of luck, because you don't know how it's built, and it might be that it's a mid or high end printer, and again the sensors will come as part of a main circuit board. But with most of those printers, since they have all these mechanisms, some sensors will need to be apart from the main circuit board, simply from the distance. So that gives you these individual units which you can then use for your own setup. So you're not stuck with just the sensor on the circuit board, but you also have some others that are left from the double-sided printing mechanism and the CD printing, for example, and you can use them for the mechanisms that you actually need for this sort of conversion. That was basically the things that you need to do in order to get it to a state where it can start moving the page also forward and also backward without having any obstacles in the way. And also to have this carriage unit move freely. With the carriage unit, there are less problems. You just need to strip the print head there. You need to clean everything, otherwise you will have a lot of ink. Here, this cable, it was thicker. It had more wires, but I've cut it nicely. I only used 4 wires from this strip, and they are connected to these ends. So basically 4 wires for the sensor here that reads the steps, the positioning. The next thing is just to test it, and that's what you saw at the beginning of this video. What I did was simply run the 2 motors in both directions just to see that they work. The sensors were not connected, but I did test them, and I just to ensure that they are working and everything is working properly. To get the pin out of these sensors, you need to simply take the sensor apart, not apart, but out of the mechanism, retrace the circuit, find the positive and the negative and then the A and B outputs. The positive will normally be the trace that has a capacitor going to the negative and also a resistor that's going to the LEDs of the sensor, so you can identify it that way. Then the other trace that has the other side of the capacitor coming to it, that will be the negative. And the two traces that don't have anything on them, they will be the A and B outputs. And by the way, if you want to know how to use these sensors, there is a dedicated video which I made a few weeks ago, and if you browse through the channel 3 videos to the back, then you'll see that tutorial, and it will explain exactly how these sensors work and how they read the position and everything like that. The next thing that I need to cover is the additions that I made to this mechanism. The first one is this strip here that you can see, and I sacrificed a box of cookies. I cut the metal from it, I worked it and made the strip. I've bent it a little bit so that the page will not run into it. It's not long enough, but that's because I initially started working with just half A4 size pages, because I removed the whole plastic here at the back that holds the A4 size pages, and they would all fall, and then the page will come in not aligned. So I just cut them and I was working with it, and that is sufficient. You can see right here that this metal strip, it has enough room for this thing. If I will later want to use A4 size pages, then I will need to make it longer so that the pen will be able to write and will not come to these ribs here and not work properly. That's the first thing that I've added. Quite simple, it's just super glued here underneath, so I can easily remove it if it's not sitting right or anything. You want to make sure that the metal doesn't touch the wheel here that needs to pull the page inwards. You want to have it just a little bit further away from it with this phase that points downwards, so that the page can just slide over it and then move to this second piece which holds the page straight. The second addition that I made was adding this sensor here. This sensor, there was an original sensor on the main circuit board, and since I removed it and I didn't feel like salvaging it out, I just used one that I had. This one will be in charge of detecting the 0 point. So the 0 point will be the point where the firmware, the code itself, will calibrate, and from there on it will start counting the steps each time. And if it loses the calibration, then it will just return to this point, and then it knows that it's at the 0 point again. And the third addition that I made was adding this pen mechanism. This mechanism only lowers and raises the pen, and it does it using the solenoid right here, and you'll see a video of it. I will here inside you will see a small video here at the bottom showing this mechanism. It's quite rudimentary, it's just for testing. And now I know that it's working right, so I can take all the measurements and I can fabricate something that will be like a single unit, and then I can also easily replace the pen. And I had this thought of maybe adding like 2 or 3 pens with different colors, and then I can also switch the different colors between them simply by having a solenoid for each one of the pens, and it will raise and lower them the way that the code will dictate. But here inside there is a spring. This spring is fixed on the bottom, the top part of the pen. It is fixed, and on the bottom part it is fixed to this plate, which I've put there, just a piece of aluminium, which I took a small part out of, and the pen rests on it, and then it's being pushed downwards by the solenoid, and it's pushed back upwards by the spring that is attached to it. It's that simple. And my next idea to improve this, and again just so that I have a more stable mechanism, is that I will simply, I thought of taking a bar, not a bar, but a piece of aluminium, bending it into a U shape, and at the bottom put another piece of aluminium, which both of them will have holes and they will be aligned, and then the pen will come through the hole and the solenoid will sit on top, and that will be a whole unit that just slides into this carriage housing here. And that's about it. It's a simple project. The main work is, again, taking apart this printer, removing all the mechanisms, disconnecting them so that we can use the forward and backward motions on the paper feeding freely. The next thing is to write code for it, which it will be the most work. I started with it yesterday. The basic approach is that I'm going to do this with an Arduino, because our Arduino is the only thing that I have. You will need for each one of the axes you will need at least 2 interrupts. That's the only thing that the Arduino can give. Only 2 interrupts, the Arduino Uno version. So my approach is to use a single Arduino for each one of the axes. So one Arduino will control the X movement, another Arduino will control the Y movement, and then a third Arduino will control them both. So basically I'm creating a controller to just operate a single axis. Both of these controllers, they will receive the data from the computer, but they will be in a disabled mode, and the third Arduino will, once everything is ready, once both the controllers have all the parameters that they need to make a line or make a sequence of lines, then the third Arduino will enable them and they will start working together in sync. Also having outputs of showing when an action has finished and when it's still in operation, so that the main Arduino knows that the X is still working or the Y is still working and it needs to wait. I went about trying to make everything on a single Arduino, but after 5 minutes I realized, well, hey, I need to have these interrupt vectors, these external interrupts. I need 5 of them at least. I need 2 for the sensors for the X, 2 for the Y, and also for this 0 point. But since I'm limited, I only have 2 Arduinos for now. Then what I'm going to do is I'm going to make one for the X, one for the Y, and this sensor I will just put it read it in the loop. It's more of a maintenance sensor than actually printing. For drawing the lines, the most important things are the 2 position sensors, and those they have to be on their own interrupts, so that we can always read the outputs live and know exactly where we are. That was about it. There are no circuits here that I can share with you. I will do it probably on the second part once I have everything ready. Basically, I just used at the beginning of this video. You saw the demonstration, and that's just an L293 chip, and it has the H bridge and just a few buttons to work the solenoid, to work the inputs to the L293, and that's it. I did try to be a wise guy with this, and at a certain point I thought, well, what if I take these output sensors and I will connect both of the outputs to an exclusive OR gate, and then I can basically only measure the points where we have one that is off and one that is on, and it works. You can count more steps. So for example, up until this point, from the 0 point up until this point, it will be 5,000 counts that it will make, and then it will stop. There is an issue of the motor slipping, which I need to overcome in some way, maybe either by compensating the slippage through code, if I see that it's a constant one, or maybe improve the circuit that I have, and just trying to get the motor to stop immediately. Even if I use the fast stop on the L293, it doesn't work. So for example, the 5,000 mark will be around here, where the 0 point thing just comes on the yellow isolation tape here at the beginning of it, but the slippage causes the carriage to move up to this point. So the length of this entire thing is slippage that comes from counting these 5,000 steps. So essentially the command of stopping the motor will carry on at this point, but the unit will slip as far as here until it comes into a dead stop. So that's an issue that I need to overcome. Here you can see markers that I made just to test a movement of 500 steps. The slower the motor goes, the more accuracy you get, but no matter how slow I tried it, to the point where it simply doesn't move anymore, you always get this slippage issue. So I need to solve that, and I'm doing that through code. That's it. I'll be honest, I thought a lot of how am I going to make this video and this tutorial, and there are so many things that I need to cover, but then I thought, well, they're not really relevant to the basics, to the essential things of this sort of project if you want to replicate it. If you want to go about it and you have any other questions, feel free to leave them in the comments and I will give you an answer. Once I get the code ready, which will be in about hopefully next week, if not then later. I have exams coming up, I don't have much time, so once I publish the code, the second part of this tutorial, you will get to see the code. You can download it, you can review it. If you have any questions, then I will also include the circuitry that I made for it. But yeah, that's it. Very simple, very easy to go about. It's just a matter of taking apart the printer and making sure that you get the two motors working, the two sensors for the motors to work, and then adding some sort of basic rudimentary mechanism that will raise and lower the pen. And you can see that I've achieved this, just pieces of aluminium, springs, tie wraps, hot glue, and a piece of wood, and that's it. So again, this was the first part, dealing with just stripping a printer, getting it to this point. The second part will come dealing with the code of this entire thing. And I hope you liked it. If you have any questions, leave them in the comments. Thank you for watching, and I'll see you next time.